Today, we're going to go through one of the most basic use cases of Cisco ACI, which is the network-centric model. This is often used when we migrate from a legacy 3-tier architecture to Cisco ACI without much changes to the network constructs or design. Now, if you look at this diagram, on the left hand side, we have the legacy network where we have some servers or VMs in VLAN 10 and VLAN 20. These connect to an L2 switch, which in turn connect to an L3 device. It is on the L3 device that we have any SVIs, ACLs, etc. When you migrate to the network centric model of ACI, this is how it would look like. So you have a tenant, a VRF. Under the VRF, for every VLAN that was there on your legacy network, we would create a bridge domain. And in that bridge domain, we will configure the subnet, which is nothing but your SVI, and you will bind this bridge domain to the corresponding endpoint group where the endpoints or servers are connected. So this is how the demo is going to look like. We will be focusing mainly on the network centric model of ACI, which is on the right hand side. So we will create a tenant, a VRF. Under that, we will create two bridge domains, one for application, other one for web. The application would be on VLAN 2013, web would be on VLAN 2014. So we will configure the subnets on the bridge domains, confirm that the endpoint is able to ping its default gateway. And finally, through the use of contracts, we will confirm that an endpoint in the app EPG is able to communicate with the endpoint in the web EPG. For this lab, the endpoints have already been configured on an Nexus 3K. This 3K is connected via a VPC to the leaves. So we have two leaves on Ethernet 1/25 is where this N3K is connected via a VPC. On the N3K, we have configured two endpoints 14, 14, 14, 14. 14, 14, 14, 4, which is in VLAN 2013, and 19, 19, 19, 1, which is in VLAN 2014. On the ACI, we will create a tenant, an application profile, or VRF. And in the network-centric model, one VLAN equals one BD equals one EPG. So we will have one BD and EPG for app and one BD and EPG for web. App would be VLAN 2013. The subnet IP or the SVI IP would be 14.14.14.14, and on web it would be 19.19.19.19, which is VLAN 2014. Now, before we could start configuring ACI, let us quickly go to the endpoints and confirm that at this moment, the endpoint can neither talk to the default gateway nor can talk to each other because ACI is yet to be configured. So as you can see on VLAN 2013, we have an endpoint 14.14.14.4, and on VLAN 2014, we have an endpoint 19.19.19.1, and the default gateway for the first one is 14.14.14.14, which will be configured as a subnet on ACI, and the default gateway for the second one is 19.19.19.19, which will also be configured as a subnet on the other bridge domain on ACI. Now, if I were to ping the default gateway from the endpoint, the ping will not happen because the ACI is yet to be configured. Let us try the same for the other endpoint as well. The communication again will not happen because the ACI is yet to be configured. We will also confirm that the first endpoint is not able to talk to the second endpoint. As you can see, this communication also does not happen. Now let us go to ACI and start configuring the objects. Let's create a tenant. Let's create a VRF. Let's create our bridge domains. The bridge domain will be part of the VRF that we just configured. And for web, the SVI IP was 19.19.19.19/24. Now we have one bridge domain. Let's configure the other bridge domain as well for app. Let's bind it to the same VRF. 14.14.14.14/24. Now that the bridge domains are configured, let's create an application profile and let's create EPGs under it. Since one VLAN equals one BD equals one EPG, we will need to create two EPGs for this scenario in the network-centric model. So let's create a web EPG, bind it to the web bridge domain that we just created, and let's create an app EPG and bind it to the app bridge domain that we created. Now on the bridge domain, on the EPG, we have to do two things. One is add the physical domain association. So this domain is what would have a VLAN pool bound to it, and this VLAN would have your VLANs allowed. In our case, we need 2013 and 2014. Both of that are allowed in this VLAN pool, which is bound to that physical domain I just added. Let's submit. Similarly, on the other EPG as well, I'm adding the domain association. Now let's create the static ports. So as I said, this is a VPC setup and this is the port group. Now since we are creating for app, it will be VLAN 2013. Finish. Similarly, we do the same for web. This is also a port channel connected on the same device, same interfaces. The VLAN would be 2014. Next and finish. So now we have the tenant, we have an application profile, we have the EPGs. The domain is mapped, which in turn is bound to the VLAN pool, and we have the necessary VLANs allowed as part of that pool. Static port, we chose on which switch, which interface, which VLAN do we want to pass. And we created bridge domains where we had the subnets or the ACIs, SVIs created, and we have a VRF which has two associated EPGs. Now, if you would like to see what was that physical domain that I added, so you can see here, physical domain. This is the physical domain which is bound to a VLAN pool, which I showed you has both VLAN 2013 and 2014 allowed in it. This is bound to an AEP, which is an associated attachable entity profile. And this AEP, you can see it over here, policies, global AEP. So whichever domain is attached to this AEP, you can see that over here. Our domain was also attached to this AEP. And finally, that would be applied on the interface profile. So our switch was 1201.1202. Let's check. So this is the policy. This is the path that I selected while choosing the static port. This is applied ETH1/25. This is the policy group that has been applied. And if you look at this policy group, shared VPC in 3K1. So let's go to interface, policy group, VPC. This is the policy group. You will see the attachable entity profile here. This is in turn bound to the physical domain, which is in turn bound to the VLAN pool where our VLANs are allowed. So this is how the access policy looks like. Now that we have this configured, let's go to our endpoint and check if the endpoints can ping the default gateway. As you can see, the first endpoint can ping the default gateway. Let's try this for the second endpoint as well. The second endpoint can also ping the default gateway. But can communication between the first endpoint and the second endpoint happen yet? This will still not work because for one EPG to talk to another EPG, by default, we need contracts on ACI. So let's go back to ACI and create a contract. So we'll create a standard contract. We can add a subject here. I'm not creating a filter here, but let me show you. You could also do it from there, or you can create a filter here. And then you create the entries. For now, I'm going to do permit ICMP. So my ether type is going to be IPv4. IP protocol is going to be ICMP, but you can create other filters as needed. And then you submit. And this filter, you bind it to your subject of the contract that you created. The action is permit. So once this is submitted, now a contract is created. We have to make sure that one of the EPG provides the contract and the other EPG consumes the contract. So this is the first EPG. I go to the second EPG and I consume this contract. Now let's go back and check if this ping works. So now the endpoint 14.14.14.4 and the endpoint 19.19.19.1 can talk to each other. You can also verify on the EPG. You will be able to see operational. So one endpoint is being learned on this EPG and on the other EPG as well. You can see one endpoint being learned. Now on the BD, if at all you were to use ACI only as layer 2, which means if your default gateway lies external to the fabric, for example on a firewall, say, in that case on the bridge domain, you would have to make this as flat and the L3 configuration, unicast routing can be disabled. This is only needed if you are having your ACI in the L3 mode, in which case I've set this unicast routing, I've created the subnet, and I've also set the L2 unknown unicast to hardware proxy. That concludes our demo of the network-centric model of ACI. And I hope that was useful for you. Thank you.